Yes, my name's Tom King, and I'm here to present on behalf of ClearChem Development. Before I get started, I just want to thank the American Chemical Society for including ClearChem in this august panel of startups. I'm very happy to be here. So in practice, I've been taking about 12 minutes to get through this, so I may have to speed it up a bit. I also want to point out that you'll see this presentation, you'll know right away it's been put together by a bunch of 50-year-old chemical and mechanical engineers as opposed to bright, young, and tech-savvy individuals. Don't get knocked by the graphics, it's more content-laden. ClearChem, I think as just said, is a company focused on pollution control, primarily from coal-fired power stations. It has a unique and patented technology that removes acid gases from combustion and does so in a manner that is both simpler and less expensive than current alternative methods, and also enables some very interesting potential operational and environmental efficiencies. So if I've got this right, hey, I like that. So, see what I mean? So, coal-fired generation is a major part of the power base in the United States and the rest of the world. It's not going anywhere. In fact, I just emailed a report from the EIA that just basically said coal is alive and well. But it does have some negative externalities, shall we say, in terms of greenhouse gases, SOx, NOx, particulate emissions, etc. The existing solutions are expensive and can be piecemeal. And both from a regulatory and from a market perspective, including the operators, uneven regulation actually leads to some pretty bad extremes where from a coal perspective, you are seeing plants either being forced to close and have profitable and important baseload generation removed, or you have the possibility of having to put in place expensive and sometimes less than reliable pollution control FGD systems, or, which is basically typical of much of the rest of the world, you end up polluting unabated. So these are not good outcomes. The market that ClearChem is focused on is the global coal market primarily. There are other uses for the technology associated with municipal solid waste burn, oil, etc., but coal is the primary market. The U.S. market, though shrinking, is still going to maintain 250 to 270 gigawatts of capacity over the course of the next 15, 20 to 30, 40 years. Internationally, the market is actually 7 times what it is in the United States, and contrary to what we see here, it's actually growing net year over year. Also internationally, 7 times larger than the U.S., but also perhaps half as likely to actually have any significant pollution control. So representing a phenomenally large market. Focused on this as a base, ClearChem has the potential to be a billion-dollar company. The solution that it offers. ClearChem very simply has a process associated with entering micronized reagents. In this case, low-cost, widely available calcium carbonate primarily. So that won't cure the common cold, but it will solve an upset stomach. It's non-toxic, very easy to handle, very flexible technology. It works pretty simply by entering micronized reagents into a furnace environment as an injection. You basically end up with a massive amount of surface area as opposed to other injected solutions. And with the residence time in the boiler and in the ducts, you end up with a vastly greater capture of pollutants. It's a flexible technology. It can be used on its own in power plants, but it can also be used, importantly, as a polishing or an agent to enhance the capture where systems are currently using FGD. It's lower cost. It comes in at about 10% of the cost on a per ton of SO2 removed basis compared to conventional FGD systems. Quick slide, bottom line here, I won't run through it. One other means that's currently being used to polish coal-fired emissions in the US is Trona, with a direct sorbent injection into the ducts. Again, the bottom line is ClearChem does it more effectively and less expensively than these other alternatives. This is where it gets really interesting. Beyond the SO2 capture that is the primary focus in the US market, ClearChem does an amazing job at scrubbing the acid gases, the corrosive gases, SO3 and HCl, primarily scrubbing all of these out of, use all, substantially all, let's say. It's never 100%. But with that, you've now eliminated the corrosive elements that come out the back of the stack. SO3 is also one of the main culprits in heavy particulate formation. So if we think about the Chinese market, even without focusing on all the other regulatory stuff that you can do, if you were to deploy the ClearChem process to coal plants in China, you could very quickly and effectively clean up most of that toxic smog that sits over Beijing and other places. If you've been there, you know exactly what I mean. So other things enabled by removing the corrosive gases from the flue gas stream include water recovery. You can now add condensing heat exchangers using non-special alloys, so lower cost and recover water from the flue gas stream. Especially here in California where water is such a big issue, the ability to potentially capture up to a ton of water for every ton of coal is pretty important. And this goes equally in China, India, and other markets. With the addition of the heat recovery technology at the back end and being able to drop the exit temperature because you no longer corrode the metals at the back end, you could potentially gain 6 to 8% in efficiency in your coal plant for a fairly modest investment. This is important for a number of reasons, but cost, bottom line, savings. You also end up with a situation where you could do a significant impact on the amount of CO2 released into the atmosphere by attacking the coal fleet. Even more exciting, ClearChem is in talks with a number of groups focused on combining this technology with others that could revolutionize, I could probably use some water, revolutionize the design of new coal plants, making them more efficient, less costly, and more environmentally friendly. Dürr is a prominent German industrial engineering firm that is a partner and is working with ClearChem on this very issue. Okay, so this slide is actually out of order, but I bothered David so much on the rest of the slides I didn't want to make the final change. Jerry Radway is the main protagonist. He's the founder and the inventor of ClearChem. He's a distinguished chemical engineer with a long career, and he's basically the father of this company. So, domestic U.S. business. Wow, who knew? So, the business model, very quickly, in the U.S., it's a licensing model with partners, channel partners to attack the U.S. utility industry. There are 2 for North America, and currently employed and deploying and working on the technology to get into the market. Internationally, it's much more likely to be joint ventures licensed with strategic international and local partners for those markets. Revenues come from 3 basic sources, maybe slightly different in the international situations, but basic license fees shared with the channel partners from the utilities for deploying the technology, royalties associated with the reagent used to capture the pollutants, and modest commissions on the installation of equipment. Some of the licensee partners, ADA, EES, are the channel partners in the U.S. focused on the market. Omnia and Imerys are large global materials players and have leading suppliers of calcium carbonate in the U.S. Dürr, I mentioned just a second ago. The rest of the team, a lot of industrial and business experience, far more so than myself. Shuman and Jerry, the founder, apologize, but they're working on a utility demonstration, so they couldn't be with us here today. Okay, so the company is tightly held primarily by principals and the founders. It is the partner organizations we mentioned before have contributed a lot toward the technology, so that's all non-dilutive capital that's helped build it up to date. The company did start last year aiming at getting a Series A done. I held them off for a year, and they're now looking for a seed funding, a seed round, and a convertible note, with the idea of doing an A round in about within a year. Everybody likes to look at numbers. The 20 million top line, these are just U.S. figures, right? This is just for a 4% rough penetration of the U.S. market. Doesn't include revenues that are unquantified, but potential from international joint ventures and or from the additional profit opportunities and penetration associated with the sort of the secondary benefits, the enabling operational efficiencies that I mentioned earlier. So this is just an early snapshot. This is just the U.S. market. So at this point, I want to say I'm going to be here through noon. I will not be here this afternoon or this evening. I'm obviously happy to anytime this morning talk in more detail. There's a lot that hasn't gone on here. I'm not a chemical engineer. Politics, economics, and business is my background, but I kind of fake it. So the gentlemen that if you want to dig in deeper, Shuman and Jerry, happy to begin to set up conversations with those guys going forward. Again, their regrets they can't join us. And at that, I'd just like to thank you for your attention, consideration, and answer some questions.
Okay, questions? In the front, please.
You indicated that your business model relies on licenses.
Mm-hmm.
Well, so I have several questions, but the first one is, have you demonstrated the technology, and can you solidly say that you can demonstrate the gains in your numbers?
Yes, there have been a number of utility boiler trials, and with steadily growing results. So the things we didn't talk about within the presentation is, yes, it does work. It is how great a capture it actually gets depends very much on the conditions of the local boiler and how you're able to get the reagent into the fireball. So you can have greater or lesser degrees. It tends to work very simply. You can put it on the coal, and you will get 40 to 50% capture just by pumping it in and allowing it to combust. To get to the higher levels of capture, and really at the highest level, we're talking 70 to 85% of the SO2, and then virtually all of the SO3s and HCLs associated with that. It's not going to, on its own, replace an FGD if you're trying to hit the sort of levels that you've got in the U.S. You can combine it with those technologies to get that last 5 or 10%, which is really what the U.S. market is focused on now. It's power plants that are maybe operating in 20 to 30% part-time or seasonal mode that don't have pollution control and are on the bubble in terms of being closed down. And then there are the plants that actually have flue gas desulfurization and other equipment installed, but in order to get to the next levels, they would have to take a risk and invest a great deal in capital to enhance the current FGD, and it's shaky. Or you could just add this technology and polish it to get close to the levels you want. There are some other benefits. And
just because I know that I have to be conscious of everybody's, but how much are you charging for the license, and how many licensees do you need to get to $20 million?
To get to $20 million on these assumptions, it's basically about 10,000 megawatts.
So how many?
Sorry, how many licensees? That's probably 2 to 600 megawatts a unit. So maybe you're talking sort of like 25 units, 25 to 30 units. Like I said, it's actually a very small penetration of the U.S. market. Having said that, there's a portion of that market that will probably half of the market will probably never be a customer for this because they either have FGD or they're fine. They're in markets where they don't have to make any changes. But it could be significantly larger than the 4% targeted, and the rates that we're looking at are small amounts per year per megawatt relative to the overall income.
All right, another question?
Is there a capital outlay to convert to your technology? If so,
Yeah.
how great is it?
It's basically $2 to $4 million per unit. It's nothing. It's decimal dust, right? I mean, compared to the amounts that you have to outlay for an FGD system if that's what you wanted to do, or even an upgrade to your existing FGD system. The main market competitor right now, which has a sort of 2-3 year head start, is direct sorbent injection, which is into it's the after the combustion, and primarily they use trona at fairly high stoichiometries. And trona is expensive. It also creates a sodium problem and leaching issues on the back end. So while it's being deployed and used, some of the externalities it's going to cause going forward and the cost associated with it, really haven't been addressed in the market. So, ClearChem in that context, there's already to some extent a path leader. Someone's within these companies, even ADA, who's our partner, also has a direct sorbent injection business. So it's another technology within their clearly.
Just another question?
Great presentation, Thomas. I mean, if you look at some other companies that have worked in this coal-fired, plant pollution abatement area like PowerSpan, I mean, the real killer there has been the timeline to having new technologies adopted. So
Yeah.
I was kind of interested that you project pretty significant and relatively early adoption of your technology.
Yeah. Well, we've worked for decades to become an overnight success. It's probably the best way. This is, I think the investors here are benefiting partially from the experience and knowledge of Jerry and the guys in here who have been developing this, the partners that they've been working with. They know it's a long haul, and it's taken a long time to get to the point where you have utilities participating. And one of the reasons that we went to the licensing model and partnership model fairly early on is the fact that you can't spend, if we were to build a company that installed and did everything associated with the technology, you could easily spend 20-30 million building it up and then wait 5 years to actually get into a utility. So you partner with guys who are already working with utilities and putting these systems on, understand the promise of the technology and are willing to play along and contribute cash and services and other things on a non-dilutive basis to get it into the market. So there are no permanent installs at this particular time. There have been a number of trials looking potentially to convert. There's another larger one coming up. I think it's scheduled for June. And then the other the other things that have been done would be enhancing some of the modeling of the boilers and the lances, the tools, if you're going to put it into the boiler that way. There was some work to upgrade that. So a lot of this stuff has been going on. But yeah, absolutely agree. So it was one of the things you're benefiting from the fact that these guys know that there's a long period of time.
There are other
that takes the
questions.
time. Yeah.
Yeah, we have time for one more brief
Okay.
question and brief response.
Okay,
Please.
so I'm gonna do two. You're gonna kill me.
Forgive my verbal.
So one of your revenue streams is, so it sounds like a bulk product, calcium carbonate that's micronized. Do they have to buy that from you? Will that be a continuing revenue stream? And then my other question is, how are investors gonna get their money back? Who's gonna take you out?
The second one's probably a better question. At least for me, an investor standpoint. Look, I'm really interested in this. I think if you stay only within the U.S., that's probably a harder question. If you end up at a $20 or $40 million top line business, you probably end up in a strategic purchase by one of the guys that's already doing the work, potentially even one of the guys that's a U.S. partner. When you take this into the global context, if you can succeed in becoming the billion-dollar company you're talking about, you've got a network of partnerships and joint ventures probably to get there. The truth is, it's probably one of those guys who ends up buying. This is not an IPO company, guys.
Very, very quickly, investment terms.
Well, generally speaking, we're talking about a convertible for the seed round.
What value?
Well, it's a convertible note, so the idea is that it converts at a discount to the A round to be done later. So we really haven't set a specific value. That'll be done by the A round investors. If somebody wants to come in and promote just the U.S. market, looking at the amounts there, I think we're looking at about a 40% IRR with a exit in 5 years, give or take.
All right, join me in thanking